Hello, my name's Diana Edwin, and I'm going to be walking you through the November 2024 paper for the Cambridge IGCSE in computer science. This is the second paper titled Algorithms, Programming and Logic. This is everything from chapters 7 through 10 in the Hodder textbook, if you're using that one. And this is assessing your programming knowledge, your understanding of pseudocode, flowcharts, SQL, logic gates, and things like that. So if you have not found this paper or taken a look at it yet, what I suggest you do is follow the link in the comments to find the paper, print it off, have a go at it. In this first part of the video, I'm going to be talking you through the section up to, but not including the final 15-mark question, which I will deal with separately. So let's go. Let's see what we've got in this paper. It's 75 marks, just the same as the theory paper. And it starts off with something nice and simple to get us going. Firstly, let's tick one box to show which check is used for verification when data is input. Okay, so the first thing we're going to just pull out is the word verification. Do you remember what is the difference between verification versus validation? Okay, we've got those two words. It's a shame they both start with a V because they are easy to get mixed up. Our validation checks are the length, the range, the type, the format, the presence check, all of those. The one which is a verification check is just visually looking on the screen and then looking at maybe your piece of paper like I've got here with my answers. I'm going to do a visual check and make sure that what is on the screen is the same as what I've got in front of me. So verification is used generally on data input manually by a user normally from one system to another. Okay. Tick one box to identify which option is used to show the inputs and outputs of a Boolean expression. Okay, so a Boolean expression, when you see Boolean, you hopefully are thinking this is a true-false type expression. So what do we use for a true-false type expression? Well, this is going to be like the logic gates in a truth table, where we could describe our truth tables as true or falses or ones and zeros. That is our option there. Now, 4 operators and 3 types of operator are shown. Draw one or more lines from each operator, so this column on the left, to its correct operator type on the right. Let's have a look at the operator types. We've got Boolean operator types. We've just been mentioning about that, haven't we? Truth tables, that kind of thing. If we've got true and false going on, that is a Boolean operator type. Arithmetic, well, hopefully adding up, subtracting, multiplication, all of those things, that comes under arithmetic. And logical statements, you may very well get these mixed up with Boolean statements because we talk about logic gates, logic circuits. But in this sense here, logical is checking, this operator is checking for things that are, for example, this first one, greater than, less than, equal to. So this one here is a logical operator. You may not have come across that, or it may not have been described to you in the course. The and, well, we know that the and comes up in a Boolean expression. We might say I've got X and Y. That is a Boolean expression, so that comes over here. Div, this is our integer division. So integer division, that is going to be a mathematical thing, so that is arithmetic. And the plus sign, also a mathematical term, so that is arithmetic. It may just have been the logical operator type which caught you out. Always just feel free to guess on the last one if you're not sure. Okay, moving on. Identify 3 stages of the program development lifecycle from the following list of words. Okay. Now, hopefully you have come across a little cycle where we've got these different stages. We start at A and we do an analysis of our problem. What is the problem we're trying to solve? And we break it down into smaller parts. Once we've done that, then we are going to design our solution. Then we will actually do the coding. And once we've done the coding, then we need to do our testing. So that is our program development lifecycle. Can we describe 3 methods that are used to design and construct a solution to the problem? So if we have been in our analysis phase up here, we might have been drawing like a little sort of top-down diagram, a structure diagram here to say, right, in order to solve this problem, we need to break it down into some parts. We may have been using a bit of abstraction to ignore some of the finer details and just to try and keep a general high-level overview of what we need to do. In the design phase, though, we need to actually look at, in a little bit more detail. So we might actually be using a structure diagram now to pull apart the actual sort of sub-programs or subsections. So if I just stated 3 methods, I'm just going to get 3 points. If I can describe the 3 methods, then I'm going to get all 6 points. So what do I use a structure diagram for in the design stage? Well, I'm going to describe what it is. It is a hierarchical diagram. That means the placement of the boxes is important. And I might use this to break down a computer program that I'm designing to solve a particular problem into, I could call them sub-programs, subsections. I could even talk about breaking down a program into functions to see exactly how I'm going to make this solution. The second thing that I might use is a flow chart. And this is really useful to consider the actual algorithm. So again, what is it? I'm going to describe it. It's a diagram. And I like to refer to it as showing the algorithm. So this is the logical thinking, or you could also talk about the ordered steps, the instructions to complete the program or to create the solution, however you want to describe that. So here's our first method that we've got, a structure diagram. The second method we've got is a flow chart. And the third method, everyone's favourite, pseudocode. Pseudocode can be used to help us design our solution. What is it? Well, I'm going to call it fake code. What does it do? Well, it describes what a program should do, what a program does, in plain language, plain English, whatever you want to use there, however you want to describe that. Okay, so it's trying to describe it in a very easy to understand way. This is what the code should do. It also helps us to then sketch out what we're doing before we actually pick which programming language we may feel is most appropriate for this particular task. Okay. Now, this has got some parts in here that maybe you have or haven't encountered before in pseudocode. This incomplete algorithm has been written in pseudocode to count the number of zeros stored in an array and total, that means sum up, or so tally up the non-zero values. Okay, so we are going to declare A as this is our array because it's got square brackets. It's not got a very helpful name, has it? It's got spaces for 50 entries, and it is of the data type integer. We are also going to declare another variable called C. Again, not very helpful. It's of the data type integer, and the same for I and T. These are really bad names, okay? And we come back to this later in the question where we decide some more appropriate names. I is being initialized to 0. There is then a blank line. We may not be able to fill in this blank line yet until we have assessed the rest of the pseudocode to see what is missing. So let's read on. For C, in the range 1 to 50, if A with an index of C meets a certain criteria that I need to put in there, then T is going to be incremented. T goes to T plus 1. Okay, so that is an increment or a counter. I'm going to count something. Else, I gets the value of I plus whatever this latest value is. So this is a sum or a running total. Okay, where we are adding up as we go along the entries in our array as we encounter them one by one. I end my if, and then again, there's a blank line. Now I need to complete the given pseudocode algorithm. So in order to do that, I need to come back and I need to look at the explanation of what it is that it's supposed to be doing. So I'm supposed to be counting the number of zeros stored in the array. Well, it looks as though this variable t is the one that is counting how many zeros are in the array. And you can see that the first place it's mentioned after it's been declared on line 4 is on line 10, where I'm saying t gets a value of whatever it was before plus 1. So unless I initialize that, I'm going to get an error on line 10 the first time I get to line 10, unless I initialize it. So that's what's missing here on line 6. What value should I give it? Well, it would make most sense that I start this tally variable on 0. And then the first time I encounter something that meets my criteria, that I'm just going to take a look at in a moment, then I increment that variable. What am I doing? I'm counting the number of zeros. So let's come back to line 8. If A, square bracket C, so this is going to take us through every item in this array one by one. What am I trying to count? The number of times I get a 0. So if this is equal to 0, then I have a 0 value which I want to add to my counter. Else, I'm going to add hopefully a non-zero value to my variable called I. I end the if statement, which I've started on line 8, and now what I need to do on line 14 is I need to complete my for loop. And to do that, I write next, and I refer to the variable that I am using to control this loop. So here it is next C. There we go. Now I need to write the pseudocode to display with suitable messages the number of zeros stored in the array and the total of the non-zero values. Okay, so I'm going to refer to the variables that I've got, but basically I'm going to display, so I'm going to output with a suitable message. So here I go, here's my suitable message. number of zeros in the array is, and then I can just put a comma. Now, which variable is it holding that? Well, it was t. And then I'm going to output the total, or the sum of the non-zero values is, and which variable am I going to use there? Well, that one was I. There we go. That's all I needed to do for that one. Now, if you look down here, they say meaningful identifiers have not been used in the algorithm. Yeah, we jolly well saw that already. So can you suggest suitable meaningful identifiers for, firstly, the array, and then each of the variables? Well, for the array, there's lots of possible answers. There's not one single correct answer. You could just do something like this. My array, or data array, or we know it contains numbers, so number array. Lots of ways you can do that. In pseudocode, we capitalize, whereas in programming languages like Python, we don't. If you just wrote it in a sort of more Python format, like data array, that would also be fine. But this is the way that we would use the capitalization in pseudocode. Now, let's have a look at these variables. These are a bit tricky, aren't they? Let's figure out what is doing what. Well, let's look at our loop counter first. We've got C being used here, and C appears all the way through here. It's our index that we're using to index into the array, and we're also using it as our loop counter. So I think potentially a good name for C might be counter, or count, or index, or something like that. Then let's look at what have we got here for T. T was the number of zeros in the array. So I think it might be quite nice to say something like, oops, I'm going to put in the wrong thing. T was zero total, or number of zeros, or something like that. Something that makes it really clear what we've got going on. I, that was the one where we've added up all of the non-zeros. So we might say sum of non-zero, or non-zero values, or something like that. You could make it smaller if you wanted, but actually, especially if you're using an IDE, which has got something like autocomplete, then slightly longer names are really helpful to distinguish between the different variables that you're using. Okay, obviously there are lots of correct answers for something like that. So let me know if you are not sure whether yours would meet the criteria or not. Okay, let's move on to question 7. We've now got a logic circuit. Firstly, can we write a logic expression for the given logic circuit? Do not attempt to simplify the logic expression. So that's great. All we need to do is we need to start naming each of these gates. So I've got a NOT gate up here at the top. And then over here, I've got an OR gate. And then this one here, I've got an XOR gate. Funnily enough, 3 marks for 3 logic gates. So W, my output at W, is going to be equal to something or something else. Let's work out what the top one is. Well, the first one is just not X. Okay, that's what I've got going into the OR gate. So it's not X, or, and then it's the result of what's happening here. And let's describe what's happening at this point here. I have Y, X, or Z. Okay, so you can work backwards like that, or you can sort of work from top to bottom. It should fall out pretty nicely to show you what's going on. Okay, now I need to complete the truth table. So you can either work from the diagram or just from this logic expression. And if you can't remember what the OR gate or the XOR gate look like, then you can just do your little mini truth table in the margin somewhere to just kind of remind you, okay, what is the output from an OR gate? Do I have one or the other? Well, I don't there, but I do there, and I do there, and I do there. My XOR gate, how is it different? Well, my XOR gate is exclusively one or the other. So those are fine, but not both. Okay, so that's the difference for my XOR gate. And not is just obviously the opposite. So I'm going to give myself a column. I'm going to call it not X. Okay, it's going to be really simple. I'm just going to look at everything in X and I'm going to invert it. Okay, may as well do it just to help me on this next part of the truth table here. Now I'm going to do Y XOR Z. Okay, so that's going to be my next column. So I need exclusively Y or Z. So what I would do is, if I was doing this on paper, I would use a pencil or something to cover up the columns that I'm not using. So I am now just looking at these columns here. So I'd really want to cover up the others so my eye doesn't jump to the wrong column. And I want exclusively one or the other, but not both. So my answers are 0, 1, 1, 0. Look at that, I've got both. That's not okay in my XOR gate. And again, 0, 1, 1, and another 0. Okay, so just pause the video, just make sure you're happy with that. And then finally, I've got my W, which is equal to my not X ORed with my final column that I've got here. So actually now I'm going to look at these two columns, the ones I've just created. Okay, and now I'm going to do an OR on those. So sometimes I just give them other names. So there's J and K. And I'm going to do J or K. So I need one or the other or both. So I've got 1, 1, 1, 1. I don't have either of them here. So now I've got a 0. 1, 1. And again, I don't have either of them. So that is a 0. Okay, so this is just a matter of being very methodical, making sure you know exactly which pattern you are following, which rule you are using to work out the answers. Just make sure, just like with any maths question, you know exactly what you're doing there. Okay, next question. A programmer is designing a program to check the length of a password and to check if the password input is the same as the stored password. The program requirements are: input the password to be stored in a variable called password. Check if there are at least 8 characters in the password. Okay, that's important. Check that the password is not the same as the stored password, stored in old pass. We're going to output accepted if both tests are completed successfully. Otherwise, I'm going to output rejected. Use the variable names given. Okay, that's just to help the examiners work out whether what you've done is the same as what is supposed to be there. So complete the flowchart for the program. So I am going to go through, I'm going to tick off the requirements as I do them. The first thing I need to do is input the password. So which shape do I need? Well, I'm going to need my parallelogram and I'm going to input password and I'm going to use it. Write it out exactly as it has been described to me up here. There we go. Tick. Job done. Now I'm going to check to see if there are at least 8 characters in the password. So now I'm going to do a little check. So I'm going to draw it quite big actually. There we go. So I'm going to say, is the length of password Now, it's got to be 8 characters or more, so greater than or equal to 8, question mark. Okay, and if it is, then that's good. So I'm going to come down here. If it is, and if it's not, I'm going to go over here to an error state, which I'll come to in a moment. Check if there are at least 8 characters in password. Done that. Now I'm going to check that the password is not the same as the stored password. So now I'm going to do another decision. Now I'm going to see, is password, now you can do it 2 ways. I'm going to say if it's not the same as old pass. Because if the answer is yes, it's not the same, that's a good thing. If the answer is no, that means it is the same and we've got a problem. What happens with our problem situation? If we don't have the tests passed, we're going to output rejected. So I'm going to output over here, rejected. Okay, and put some more arrows in there. If it's okay, then I'm going to output accepted. Just like it described to me in the question. And there we go. And then we finish. So I'm going to come back up and take a look. Have I checked that the password is not the same as the stored password old pass? Yep. Have I output accepted if both tests are completed successfully? Yep. Otherwise, output rejected. I've used the variable names given. So there we go. And you can see how scrappy that is. You might want to do that in pencil. You can see I almost ran out of space, didn't I? So it might be something that you want to do in pencil just to get going on that. Okay, now the accepted password. Password is to be written to the file mypassword.txt. Write pseudocode to open the file, write the accepted password to the file, and close the file. Now this is just the most straightforward thing to do, as long as you know that in pseudocode, everything is written in capital letters. So all of our key commands, and we just use a single word open file. That is our command. And I need to say, well, which file to open? Well, they've told me which file to open. And now when I open a file, I can either open it for just reading, in which case I would say for read. That means I don't risk accidentally deleting something or changing something. But because I want to write to the file, I'm going to open it for writing to it, for write access. Now I need to write something into the file. So that is just written like this. Write file. I'm going to say, which file am I writing to? That is important. And what am I writing? Well, it's whatever is stored in the variable password. Close the file. I bet you can guess what it is, even if you didn't know before. Close file. Which one am I closing? Password.txt. Okay, now if you've not seen anything like this before, just pause, take a look at this, see how common sense this is. Pseudocode is not supposed to be difficult. It's supposed to be communicating clearly what you need to carry out in your programming language. Okay, so it should be that anyone could look at this and go, well, I can guess what this is doing here. So that is what the pseudocode is trying to do. We're going to open a file for write access. We're going to write password into it, and then we're going to close that file again. Okay. Now, can we explain why the accepted password needs to be stored in a file? Now, this is the sort of thing which kind of draws on what we've been practicing for the theory paper. Why do we want to store it in a file? Maybe so it can be retrieved later. when needed. So it can be stored for a later date, that sort of thing. Anything like that is going to get you a mark, showing that you understand when you put it in a file, that means you will have access to it at a point in the future. Now, rather confusingly for this mark scheme, the other thing which they wanted you to specify was that this file storage, if we just stored this file in RAM, then as soon as we switched off, we would lose that password. We'd lose that file, so we wouldn't have it. So the file storage, wherever we store that file, it must be in non-volatile memory. Okay, so we can't store it in RAM, not permanently. We would need to actually save that file to secondary storage somewhere so that we would have it at a later stage. And that idea was going to get you the second mark there. That's the type of thing where, as a tutor, I'm looking through that and thinking, right, that's really hard for you to know that that's what they were looking for. So I'm not expecting anyone really to come up with an answer like that. Hopefully you'll get the 1 mark. Okay, now here is a what's gone wrong with the pseudocode question. Can we spot the errors? What we need to do here is we need to read through the description of what the pseudocode is supposed to be doing and then analyze it to see if it is actually doing what it's supposed to be doing or if there's a problem with it. An algorithm has been written in pseudocode to check if a temperature is in a given range. The temperature values used in the algorithm are correct. Okay, let's just read that again. An algorithm has been written in pseudocode to check if a temperature is in a given range. The temperature values are correct. Okay, so there's not an issue with the numbers 38.0, 35.0. Those are the correct temperatures that they want us to use. There are other errors that we now need to work out what they are. So let's have a look at the first thing here. We have got a repeat loop. Now, a repeat loop is something that we have in pseudocode and we don't have it in Python, so you might not be as familiar. Repeat is paired with the word, is it while? Is that correct? We repeat something while something is true? No, that's not right, is it? So even though it's at the bottom, straight away I've spotted there's an error on line 19. It should be repeat until something is true. And it looks like this is correct, but you might just want to leave that until you've decided if that is correct. Okay, so kind of that is something that we might just write down the word until. Repeat until. There we go. That's the first thing that I have spotted. Okay, let's now go into the loop and see what's happening inside the loop. I'm going to output, please enter the temperature. I'm going to input a value and I'm going to store it in temp. Then on line 4, if temperature equals 999, okay, already I can spot a problem. Can you see the problem here? We've got the variable temp and then the variable temperature. I think they're supposed to be the same thing, aren't they? And you can see that throughout the rest of the pseudocode, they've used the variable name temperature. So I am going to say that the error has been on line 3 and that this should have actually been temperature. Let's do that. Error on line 3, correction, input, temperature. Okay, let's come back to the code and let's see what's going on. So I fixed that. If temperature is equal to 999, then I'm going to do the following. Well, if the temperature is 999, it's never going to be less than 35, is it? So line 10, like that would never happen. What do we know about numbers like 999? Well, quite often they are either given as a maximum or a minimum initializing value, or it may be a number which jumps us out of the program and is the number which we're looking for to exit the loop. And if you remember, we've already spotted this, haven't we, down on line 19? We're going to repeat the following until temperature equals 999. So this is basically our exit condition. Okay, which is here. This is our real exit condition. So do we want to check for our exit condition inside the loop? No, we don't. We want to make sure that this is not equal to 999. So this is wrong. So we've got an error on line 4, and I'm going to have to bring it down here. An error on line 4. And we need to use the pseudocode version of not equal to, which I just used in the flowchart earlier. This is how we write not equal to. Okay, if by any chance you use the Python not equal to, then yeah, depending on whether they're feeling generous, they might give it to you or not. Okay, but this is how we write that in pseudocode, not equal to. So there we go. So there's that one. So if temperature is not equal to 999, then we're going to go on, we're going to check. Then if temperature is greater than 38, then I'm going to print temperature too high. And if I'm going to end if the temperature is less than 35.0, then I'm going to output temperature too low. This all seems quite logical, and I'm going to end the if statement. If the temperature is greater than or equal to 35, or the temperature is less than or equal to 38.0, then I'm going to output temperature normal. Now, this is a little bit more complicated, isn't it? Let's take a look at this. Let's pick a number which we should expect to get the reading, the output of temperature normal. Let's say a number like 36. So, is 36 greater than or equal to 35? Yes, it is. Or is it less than or equal to 38? Yes, it is. So 36 works. Let's pick another number. Let's pick the number 40. If 40 is greater than or equal to 35, which it is, then I don't need to go any further. I don't need to look at the or. I've already got the first part of this condition being true. So this is wrong. I don't want either one or the other to be true. I need both of them to be true. The number has got to be within this range. It's got to be greater than 35 and it's got to be less than 38. Okay? Otherwise, we're going to get some anomalies. So my error is on line 14. And I could blah, 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 if, and then I'm just going to write and in there. And if you've got time, you could fill in exactly what that line should look like. Okay. Now let's identify the temperature range used. Actually, well, I might see if I can get all of this on the page. There we go. So now I know it's gone a bit small, but just so you can see, I can make it a little bit bigger. There we go. So you might need to zoom in on this now. So can we identify the temperature range used? Well, we have got our temperature range. This is what we're looking at in here. This is what is going to be okay. So we could say something like between 35.0 degrees and 38.0 degrees. Now, if I use this special word, inclusive, that means that's helping us to say it's greater than or equal to 35 and less than or equal to 38. So those are included. Also, you could write it out like it is expressed in the if statement here on line 14. You could say temperature is greater than or equal to 35 and less than or equal to 38. So that would also be another way of writing it. Now we need to complete the trace table for the corrected algorithm using this data. So now we need to go through this algorithm here. We are going to repeat the following until temperature equals 999. So the first thing I'm going to do, I'm going to look at over here on my, I'm going to start at line 2. I'm going to repeat the following. Please enter temperature. That is the output. So that is where you should start. Then I'm going to input the temperature. I've got this set of inputs, and because I'm now on the left-hand side again, I'm going to put that on a new line. So 34.22, I've done that. I am going to cross it off so that I can clearly see that I have read in that value. Now, this one here is going to be sort of not equal to, so temperature is not equal to 999. So then I go on. Line 6 is if temperature is greater than 38. No, that's not going to happen. Line 10, if temperature is less than 35. Okay, this is true. So I'm going to go in line 11. Line 12, I'm going to output temperature too low. Okay, because I've gone into that if statement and I'm there on line 12. End if. Is it greater than or equal to 35? No, it isn't. Fine. So now I'm going to loop around and now I'm going to go back to the start because temperature is not equal to 999. So here we go. Please enter temperature. What's the next one? 36.1. That's not 999, so on I go. It's not greater than 38. It's not less than 35, so that's lines 6 and 10. Is it greater than or equal to 35? And is it less than or equal to 38? Yes, it is. So line 14 is true. So then I'm going to go to line 16. I'm going to output temperature normal. Can you see how that has happened? Okay, cross that off. Okay, what do I do? Well, I'm going to get the please enter temperature. And then I'm going to read in my next one. Round I go. What's my next value? 37.4. Is it greater than 38? No. Is it less than 35? No. Is it between 35 and 38? Yes, it is. So I'm going to get temperature normal being printed out again. Okay, round we go because we're still not at 999. What's the next one? 38.0. Okay, this is testing the boundary, isn't it? Is the temperature greater than 38.0? It isn't. It's equal to, isn't it? So I don't get the message temperature too high. I'm going to get the temperature normal message. Okay, round I go again. Please enter temperature. What's the next one? 999. Here we go. Right, and now I'm on line 4. If temperature is not equal to 999, I do the following. Well, it is equal to 999, so I don't do that. So I jump from line 4 straight down to the end if here on line 18, and I repeat until temperature equals 999, which it does. So I stop. So there's nothing else that goes into that trace table. The trace table is now complete. And this is really important for you guys to remember, that there may very well be data in here that is not entered. We don't get to that point. Okay, so you can't just copy in all of the data from that list, because you may not be using all of it. Okay, so there we go. So that was us following through that trace. Right, okay. The next one, should have gone back to this. Here we go. Try and get this back on the screen. There we go. Pretty much see all of this. The shop that sells cheese has set up a new database table called cheese stock to store details of the cheeses available for sale. Part of this table is given. Date the number of records in this part of the database table. What is a record? Well, a record is a row. So let's count the rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 rows, 19 records. Okay, nice and simple. Give the name of the field that would be used for the primary key. Okay. This is the same as ever it is. And why do we use this field? We need a unique field, don't we? And that will be our reason in a moment. Which of these fields is clearly here to give us a unique identifier? Well, it is CH number. I guess that stands for cheese number. State the reason for choosing this field. It is unique. If you don't want to write any more, or it is unique for every record in the table. That is what we are saying there. Okay. So that is the first part of the SQL question. It's pretty much the same each time. Now then, can we write the output from this SQL statement? I'm going to select, that means I'm going to show in my answer the fields CH number and weight. So that means I'm going to have two fields in my answer on each line from the table called cheese stock. Lovely, good, that's the one, cheese stock. Yeah, I'm finding the data in the right place. Where, and this is my search criteria, the supplier code equals ABC. So I'm firstly going to do my search. I'm going to look in supplier code and I'm going to find the ones that have got ABC. It's just those two. What that means is I'm going to have two lines in my search results. But I'm not going to copy out the entire row. I'm just going to pick out the CH field, CH number field, and the weight kilogram field. So here we go. So here's the first one, CH04. And then the weight in kilograms, 0.0. That's the first one. The next one, CH05. That's the CH number field. And then the weight in kilograms, 50.0. Okay, that is all they want to see. But you've picked the right fields, you've printed them out. They will give you the, at least the number of lines that you need. So you print out every answer for each record on a different line in your answer booklet there. Now, can we complete this SQL statement to display only the name? Okay, we need to work out which field that is, of all of the cheeses that are out of stock. Okay. So where it says to display only the name, that means we are going to select only the field which has the name information. And there it is up there, name. Where am I selecting this information from? Well, it's from the table named cheese stock. We need to specify that really clearly. Where, now here's my search criteria. How am I going to find the ones that are out of stock? Well, I've got a very nice field called in stock. So I could check in stock, couldn't I? So I could say where in stock is equal to no. I could also write in stock equals no. I could put it in speech marks. That would be fine as well. Explain how one of the lines in your statement in part DI, what we've just answered, could be changed to display the same information. Is there another way that we could get the same results shown? Well, we need to show the cheeses that are out of stock. We could have chosen where in stock. We could actually call it a Boolean. We could write it like that, where in stock equals false, because it's a Boolean field. It's only got the values yes or no, which would be referred to as true or false as well. But there is another field which might help us. And actually, maybe you've spotted it. It's the weight. This is obviously showing the weight of cheese that they've got available. So if weight is equal to 0.0, exactly how they've written it there, that probably means they don't have any in stock. And if you check across, look at these are not in stock, and they've got a value of 0. This one's not in stock, got a weight of 0. So you can double check across the fields and see that the ones that are not in stock have got a weight of 0. Okay, so that is how we would answer that one. I quite like that one because that's a little bit more interesting than some of the other SQL questions that we've had in the past. Now that's the end of this video because I'm going to be looking at the extended programming question in another video. So I hope that was helpful and I'll see you in the next one.